Curve has equation y equals to x cubed minus 6x squared plus 16. Find the coordinates of the two turning points. So turning points are the same as stationary points. So what we do is we first find the derivative of this equation. dy by dx equals to 3 times x to the power of 3 minus 1 minus 6 times 2 times x to the power of 2 minus 1 plus 0. So that's going to be 3x squared minus 12x. That is your dy by dx of the curve. Now we put our dy by dx equal to 0. So it's going to be 0 equals to 3x squared minus 12x. Factorize it, 3x common, so x minus 4. 3x equals to 0 and x minus 4 equals to 0. One value of x is 0 and the other value is 4. Now, since it says find the coordinates, so what we will do is we will substitute x equals to 4 and x equals to 0 in the equation of the curve and find the corresponding y values. At x equals to 0, y will be equal to 16. And at x equals to 4, y is going to equal to 4 cubed minus 6 times 4 square plus 16, which is 176. So one coordinate is 0, 16, and the other coordinate is 4, 176. These are your turning points of the given curve. The next question they're asking us to determine whether each of those turning points are a maximum or minimum. So to find the nature of a turning point, we differentiate the first derivative. So what we do is we find the double derivative, which is going to be 3 times 2 times x to the power of 2 minus 1 minus 12 times x to the power of 2 minus 1. It is going to be 6x minus 12. Now we will put x equals to 0 in our double derivative. So d square y over dx square equals to 6 times 0 minus 12, which is minus 12. Since our double derivative is less than 0, that means it's a maximum point. Now, if we put x equals to 4 in the double derivative, we get 6 times 4 minus 12, which is 24 minus 12, and that's 12. In this case, our second derivative is greater than 0, which means it's a minimum point.